Hello, welcome back. In this lesson, we are going to learn about types of signals. So, let's look at the agenda. We will be learning about energy signals and power signals. Now, what is an energy signal? An energy signal is a signal which has finite energy and zero power. Let's say we are having an energy signal GT. So the energy of the signal will be given as Eg is equal to minus infinity to plus infinity GT dt G square T dt. So this is the equation for finding out the energy of the signal. Now, one requirement that the signal GT is an energy signal is that the signal amplitude should tend to 0 at t tending to infinity. So this is one requirement. So the energy signal will have finite energy and zero power. Let's take the example. Let's say we are plotting here t and we are plotting the amplitude along this axis, and let's say this is gt. This is of the form like this. Let's say this is of value 1 here and this is 2. So this is an example of an energy signal. Let's say this is e to the power minus at, where a is an integer. Now, how to check that this is an energy signal and not a power signal? Okay. Let's take another example. Let's say we have gt is equal to e to the power minus at into ut, where a is greater than 0. Ut is the unit step function. Whenever we multiply any signal with ut, the resultant will be starting from 0 value. So gt will start like this. Okay. So how do we find out the energy? Eg is given as, according to the equation, minus infinity to plus infinity e to the power minus at whole square dt. Now since this is multiplied by ut, so we will have it 0 to infinity e to the power minus at whole square dt. So it will be e to the power minus 2at dt, 0 to infinity. So answer will be 1 by 2a. We can find that we have finite energy. So this is an example of energy signal. Let us understand what a power signal is all about. If we have a signal gt, the power of the signal pt is given as 1 by t minus t by 2 to plus t by 2 g square t dt. Here t tending to infinity. Now all bounded periodic signals are power signals because their power is finite and energy is infinite. So power signals have finite power and infinite energy. So an example of power signal can be if GT is equal to A. That means GT is equal to A means this is the value of the signal. Now if you want to find out the power of the signal, PG is equal to T tending to infinity 1 by T minus T by 2 to plus T by 2 A square dt. So this is going to be equal to A square into so we get it like this, A square T by 2 plus T by 2 will be equal to A square. So we can find that it has finite power, but the energy of the signal is not zero. The energy of the signal is not finite because you see the signal value does not tend to zero as t tends to infinity. So this is an example of power signal. We can have a signal which is neither an energy signal nor a power signal. The ramp signal is neither an energy signal nor a power signal. Because for the ramp signal, the nature of the ramp signal is like this. You can see here, this is not a periodic signal. And also its amplitude does not tend to zero as t tends to infinity. So this ramp signal is an example of a signal which is neither an energy signal nor a power signal. So in this lesson, we have learned about the different types of signals like energy signal and power signal. And we have been able to make a comparative analysis of which signal will be an energy signal and which signal will be a power signal. We have seen that, and for an energy signal, the signal energy should be finite and power should be zero. And for a power signal, the power should be finite and energy should be infinite. An example of a signal which is neither a power signal nor an energy signal is a ramp signal. We have seen that. And here we come to the end. Thank you.